Mysterious gigantic carbon cocoons discovered surrounding growing galaxies. Researchers have discovered gigantic clouds of gaseous carbon spanning more than a radius of 30,000 light-years around young galaxies using the Atacama Large Millimeter Submillimeter Array, ALMA. This is the first confirmation that carbon atoms produced inside of stars in the early universe have spread beyond galaxies. No theoretical studies have predicted such huge carbon cocoons around growing galaxies, which raises questions about our current understanding of cosmic evolution. We examined the ALMA Science Archive thoroughly and collected all the data that contain radio signals from carbon ions in galaxies in the early universe, only 1 billion years after the Big Bang, says Seiji Fujimoto, the lead author of the research paper, who is an astronomer at the University of Copenhagen, and a former PhD student at the University of Tokyo. By combining all the data, we achieved unprecedented sensitivity. To obtain a dataset of the same quality with one observation would take 20 times longer than typical ALMA observations, which is almost impossible to achieve. Animation of the ALMA and NASA ESA Hubble Space Telescope, HST, images of a young galaxy surrounded by a gaseous carbon cocoon. The red color shows the distribution of carbon gas imaged by combining the ALMA data for 18 galaxies. The stellar distribution photographed by HST is shown in blue. The gaseous carbon clouds are almost 5 times larger than the distribution of stars in the galaxies, as observed with the Hubble Space Telescope. Credit, ALMA, is only a Gennaro, NASA ESA Hubble Space Telescope, Fujimoto et al. Heavy elements such as carbon and oxygen did not exist in the universe at the time of the Big Bang. They were formed later by nuclear fusion in stars. However, it is not yet understood how these elements spread throughout the universe. Astronomers have found heavy elements inside baby galaxies but not beyond those galaxies, due to the limited sensitivity of their telescopes. This research deemed some of the faint signals stored in the data archive and pushed the limits. The gaseous carbon clouds are almost 5 times larger than the distribution of stars in the galaxies, as observed with the Hubble Space Telescope, explains Masumi Oichi, a professor at the National Astronomical Observatory of Japan and the University of Tokyo. We spotted diffuse but huge clouds floating in the coal-black universe, young galaxies surrounded by a gaseous carbon cocoon. ALMA and NASA ESA Hubble Space Telescope, HST, image of a young galaxy surrounded by a gaseous carbon cocoon. The red color shows the distribution of carbon gas imaged by combining the ALMA data for 18 galaxies. The stellar distribution photographed by HST is shown in blue. The image size is 3.8 arcsec x 3.8 arcsec, which corresponds 70,000 light-years x 70,000 light-years at the distance of 12.8 billion light-years away. Credit, ALMA, is only a Gennaro, NASA ESA Hubble Space Telescope, Fujimoto et al. Then, how were the carbon cocoons formed? Supernova explosions at the final stage of stellar life expel heavy elements formed in the stars, says Professor Rob Iverson, the Director for Science at the European Southern Observatory. Energetic jets and radiation from supermassive black holes in the centers of the galaxies could also help transport carbon outside of the galaxies and finally to throughout the universe. We are witnessing this ongoing diffusion process, the earliest environmental pollution in the universe. The research team notes that at present theoretical models are unable to explain such large carbon clouds around young galaxies, probably indicating that some new physical process must be incorporated into cosmological simulations. Young galaxies seem to eject an amount of carbon-rich gas far exceeding our expectation, says Andrea Ferrara, a professor at Scuola Normale Superiore di Pisa. The team is now using ALMA and other telescopes around the world to further explore the implications of the discovery for galactic outflows and carbon-rich halos around galaxies. Paper in the research team. These observation results are published as S. Fujimoto et al. First identification of 10 kpc, Ci, halo around star-forming galaxies at Z equals 5 to 7 in the Astrophysical Journal on the 16th of December, 2019. The research team members are Seiji Fujimoto, the University of Tokyo National Astronomical Observatory of Japan Waseda, University, current affiliation is University of Copenhagen, Masumi Oichi, National Astronomical Observatory of Japan, the University of Tokyo, Andrea Ferrara, Scuola Normale Superiore di Pisa, Andrea Pilotini, Scuola Normale Superiore di Pisa, Rob J. Iverson, European Southern Observatory, Christopher Behrens, Scuola Normale Superiore di Pisa, Simona Gallerini, Scuola Normale Superiore di Pisa, Shohairta, Osaka University, Hidenobu Yajima, University of Tsukuba, and Kintaro Nagamian, Osaka University. The University of Tokyo, University of Nevada. This research was supported by World Premier International Research Center Initiative, WPI Initiative, MEXT, Japan, JSPS Kakenhi, number 15H02064, 16J02344, 17H01110, 17H01111, 17H01114, Neojilma Scientific Research Grants number 2017-06B, Munich Institute for Astro and Particle Physics, MIAP, of the DFG Cluster of Excellence Origin and Structure of the Universe, 2018 Graduate Research Abroad in Science Program Grant, GRASP 2018. The Hayako Asatio Fund awarded by the Astronomical Society of Japan, and the UG Advanced Grants Interstellar Age 2020/7,40,120 in Cosmic ISM 3,21,302. The Atacama Large Millimeter Submillimeter Array, ALMA, an international astronomy facility, is a partnership of the European Organization for Astronomical Research in the Southern Hemisphere, ESO, the U.S. National Science Foundation, NSF, and the National Institutes of Natural Sciences, NINS, of Japan in cooperation with the Republic of Chile. ELMA is funded by ESO on behalf of its member states, by NSF in cooperation with the National Research Council of Canada, and RC, and the Ministry of Science and Technology, NMOST, and by NINS in cooperation with the Academia Sinica, AS, in Taiwan and the Career Astronomy and Space Science Institute, KASI. ELMA construction and operations are led by ESO on behalf of its member states, by the National Radio Astronomy Observatory, NRAO, managed by Associated Universities, Incorporated, AUI, on behalf of North America, and by the National Astronomical Observatory of Japan, NAOJ, on behalf of East Asia. The Joint ELMA Observatory, JAO, provides the unified leadership and management of the construction, commissioning and operation of ELMA. Please save trees and nature. Please subscribe my channel. Mysterious gigantic carbon cocoons.